بسم الله الرحمن الرحيم. I'm Dr. Hamdi Saber, MD, Head of ICU Department in Saudi German Hospital, Cairo. We will speak today about the basics of mechanical ventilation. My topic mainly is not directed to ICU physicians or residents. It is directed to whom is not practicing ICU for a long time in their medical practice. This is just a very basic preparatory course speaking about basics of mechanical ventilation. Basically, mechanical ventilation is a useful modality for patients who are unable to sustain the level of ventilation necessary to maintain gas exchange function and the carbon dioxide elimination. Indication of mechanical ventilation include a wide range of clinical presentation, starting from acute ventilatory failure like apnea, bradypnea, acute lung injury, impending ventilatory failure like progressive acidosis and hypoventilation and CO2 retention, severe hypoxemia when PO2 less than 40 and BF ratio less than 300 like an acute lung injury, prophylactic ventilatory support and post anesthesia, muscle fatigue, and neuromuscular disorder. Goals of mechanical ventilation is basically to reverse the causative pathology that caused respiratory failure, like improving gas exchange and reversing hypoxemia and respiratory acidosis, relieve respiratory distress and reduce oxygen cost of breathing like patient of circulatory failure, improve pulmonary mechanics to prevent and reverse atelectasis and improve compliance, permit lung and airway healing and maintain lung and airway functions and avoiding complications. Then we start to classify the ventilatory modes into support modes and control modes. Support modes aims to help the spontaneous breathing of the patient, like pressure support ventilation, continuous positive airway pressure ventilation, CPAP, PEEP with the positive end expiratory pressure, which is not a real mode of ventilation. And control modes, either pressure control mode with target pressure to be achieved during each breath timed, or volume controlled mode with target volume to be delivered by in each breath timed, SIMV mode, combined mode. Here we can see the ventilator graphic or waveform display. The pressure in the upper, the flow in the middle, and volume in the lower part. In the pressure controller, as you can see in the left part, with target pressure to be set and to be achieved during pressure controlled ventilation, which is the target in pressure controlled modes. First, we will start speak about the modes of mechanical ventilation. First, we will start by volume controlled ventilation or volume target ventilation. There are different modes that will apply the volume controlled ventilation. Volume control means that we set a volume delivered each breath, and the volume is fixed. Pressure will vary depending upon pulmonary compliance and airway resistance. The advantage of volume control is the ability to regulate both tidal volume and minute ventilation. Although the ventilator will deliver pressure to ensure volume delivery within the alarm limits. The first mode of the volume control mode is the assist control mode, which will be displayed on the ventilator like ASV mode. In this mode, the mandatory mechanical breathing may be either patient triggered by the patient effort or by time trigger, means that we set a rate of the ventilator of 12, that the ventilator will deliver a breath every 5 seconds. If the patient trigger the ventilator at any time before the 5 seconds elapses, the ventilator will give a mandatory machine breath. If the 5 seconds elapsed, the machine will deliver the breath by time trigger. Inspiration, the assist control is terminated by volume cycling. When the preset tidal volume is delivered, this ventilatory mode provides full support for patients when they are first placed on mechanical ventilation. Assist control mode is used in patients with a stable respiratory drive and they can trigger the ventilator into inspiration. Their main advantage is that they reduce the work of breathing and give full support to the patient, and they used at the initial mode of ventilation immediately after intubation in many patients. As the assist control mode allow the patient to control the frequency of respiration and the minute ventilation, allowing the patient to normalize his BaCO2. Complications: if the patient is hyperventilating and every breath is given by the machine, the patient can easily develop respiratory alkalosis. We will give a hint about the controlled mechanical ventilation mode, which is the SIMV, which is rather available in older generations of ventilators and now replaced by the ASV. Here the ventilator is giving a preset volume controlled breaths at a preset rate, not looking for patient trigger or synchronization. It is used for ventilating patients whom are totally paralyzed and sedated or under anesthesia. It is very bad for patient ventilator synchronization. This is why it is replaced totally by ASV. Pressure controlled ventilation. In pressure controlled ventilation, the pressure is the target. The pressure remains constant. Volume and minute ventilation will vary with the change in the patient pulmonary compliance or airway resistance. The ventilator targets a peak in inspiratory pressure and will deliver the pressure, and then the volume will be delivered and the minute ventilation depend on the respiratory rate. Its advantage: it produces a little less airway pressure, mean airway pressure, that may protect the lung from excessive pressures and preventing ventilator-induced lung injury. In pressure-controlled ventilation, the pressure-controlled breaths are time-triggered by a preset respiratory rate. Means the ventilator delivers at a set time determined by the rate certain pressure with a peak pressure. And the value of pressure-controlled ventilation that it reduces mean airway pressure and reduce the exposure of the lung, especially stiff lung like ARDS, to excessive airway pressure, aiming to reduce complication. Here we will start to speak on synchronized intermittent mandatory ventilation, which is a mix between fully controlled mode, which can be either pressure or volume, and spontaneous mode using pressure support ventilation. Here, the ventilator delivers the mandatory breaths to the patient at or near the time of spontaneous breath. Hence, the mandatory breaths are synchronized with spontaneous breaths. Patient triggering might be based on either pressure or flow. During the time interval just before the mandatory breath is being delivered, the ventilator is responsive to the patient's spontaneous respiratory effort, and this is called indication for synchronized intermittent mandatory ventilation. The primary indication of SIMV is to provide partial ventilatory support to the patient. mainly during weaning patient and aiming to reduce support gradually. Advantage of SIMV mode: maintains respiratory muscle strength and avoids muscle atrophy, reduces ventilation to perfusion mismatch, decreases mean airway pressure, and facilitates weaning. SIMV mode at the mode of weaning was currently replaced by the pressure support ventilation and the gradual decline in the pressure support. SIMV mode can enhance and induce high work of breathing during weaning and cause weaning failure. The first mode of spontaneous breathing is the pressure support ventilation. Basically, it's a pressure controlled ventilation, means it's a pressure limited, patient triggered, and flow cycled ventilation. There is no rate to set, nothing will be set. The patient controls the rate, and the patient triggers the ventilator each time he inspires. After he inspires, the ventilator delivers a set pressure that you will set either 10 or 20 centimeters of water. This pressure delivered will help the patient to inspire, and the flow of inspired air will be monitored. After decline of flow, at the end of inspiration, the ventilator to exhale to expiration. It's a patient triggered, pressure limited, and flow cycled ventilation, aiming to give support to the patient, lower the work of spontaneous breathing, and augments patient's spontaneous tidal volume, mainly used during weaning. Combining pressure support ventilation and the synchronized intermittent mandatory ventilation significantly lower the oxygen consumption requirement and may help to reduce the work of breathing. Pressure supported breaths are considered spontaneous because they are patient triggered. The tidal volume varies with patient inspiratory flow demand. Inspiration lasts only for as long as the patient activity inspires, and inspiration is terminated when the patient inspiratory flow demand decreases to a preset minimal level. As you can see from the figure, a preset pressure is applied to the patient airway for the duration of spontaneous breath. It lowers the work of spontaneous breathing and augments the tidal volume of spontaneous breath. It also can be used with SIMV mode to facilitate weaning in difficult to wean patients. The main indication of pressure support is weaning from the mechanical ventilation. But some disadvantage: pressure support ventilation is not an ideal mode for patients with unstable respiratory drive or hypopnea. Also, if the patient is severely hypoxic and needing a higher pressure support ventilation may be not the ideal. Another mode of spontaneous breathing mode is the continuous positive airway pressure, or CPAP. CPAP means that the airway pressure never goes back to zero. It functions similar to PEEP. It means a delivery of continuous level of positive airway pressure. The ventilator does not cycle or give any breaths during, only allowing the patient to inspire and exhale during a higher basic airway pressure, which is a CPAP. And the patient must initiate all breaths. Most commonly used in the management of sleep-related disorders, is of a great help during pulmonary edema, like PEEP, and also in obesity hypoventilation syndrome. Here we can see what happens during CPAP. A basic pressure is applied the whole respiratory cycle. A positive index respiratory is applied the whole respiratory cycle, and the patient can breathe in and out spontaneously. After selecting the mode of ventilation, as we have displayed, we will start to set up the ventilator and adjusting the knobs of the ventilator. We'll set the tidal volume, respiratory rate, FiO2, PEEP, flow rate, and I ratio. After setting the mode, in volume control mode, we start to set the tidal volume. Usually it is set between 6 and 8 milliliters per kg of the predicted body weight. Using smaller tidal volume may be indicated in ARDS or severe lung injury patients like we are facing nowadays. After we set the mode and the tidal volume, we will set the rate, the number of breaths per minute that is intended to provide the eucapnic ventilation or normal CO2 for the patient. The initial frequency is usually set between 12 and 16 per minute. Higher frequencies may be associated with dynamic hyperinflation or O2B, especially in COPD or asthma patients. Then we start to set up the fraction of inspired oxygen. The initial FiO2 may be set at 100% and should be evaluated by means of blood gas after stabilization of the patient, usually within 30 minutes. And the FiO2 should be adjusted accordingly to maintain a PaO2 in the blood gases between 18 and 100. After stabilization of the patient, we aim to reduce the FiO2 the best to keep below 50% to avoid oxygen-induced lung injury. And reduction of the delivered oxygen of FiO2 can be assessed by maintaining a saturation above 90-95 or frequent blood gases. PEEP is the positive inspiratory pressure, meaning that the airway pressure never goes back to zero in controlled ventilation, either pressure or volume. Its main target is that it free inflates the collapsed alveoli and supports and maintains alveolar inflation during exhalation. Also, it increases the functional residual capacity and also useful to treat refractory hypoxemia. The initial PEEP level may be set at 5 cm of water, and the ARDS and in similar viral pneumonia conditions we may start by 10 cm of water. The next step, after setting the rate, the FiO2, and the tidal volume, we'll set the PEEP. The basic principle is that PEEP reinflates the collapsed alveoli and maintains alveolar inflation during exhalation. PEEP also lowers the alveolar distending pressure and facilitates gas diffusion and oxygenation. This advantage includes decreasing in the venous return, barotrauma, increased intracranial pressure, and also alteration in renal function. After setting the previous parameter, we will set the flow rate. The flow rate or the peak flow rate is the maximum flow of air or the speed of air delivered by the ventilator during inspiration. The inspiratory flow needs to be sufficient to overcome pulmonary and ventilator impedance. Otherwise, the work of breathing is increased. The peak flow rates of 60 liters per minute may be sufficient or starting number after in the initial ventilatory setting, especially in volume-controlled ventilation. Higher rates are frequently necessary in patients with bronchoconstriction. As we can see in the figure, an insufficient peak flow rate is characterized by dyspnea, scalloping of the inspiratory pressure tracing, as you can see, and seriously low peak inspiratory pressure. Then we will set up the I ratio, which is the ratio between the inspiratory time and the expiratory time. The inspiratory to expiratory time is usually kept in the range of 1 to 2 to 1 to 4. A large A ratio may be used to reduce air trapping and O2 while inversing A ratio by a ratio of 1 to 1 or less, 0.9 to 1, may be used in prolonged inspiration to correct refractory hypoxemia in ARDS patients. Adjusting IA ratio is usually an interplay between the whole parameters we set. It is affected by flow rate, increasing or decrease or decrease tidal volume, increasing frequency or decreasing frequency. Any change in the flow rate will increasing flow rate will decrease inspiratory time. Increasing respiratory rate will decrease the inspiratory and the expiratory time. Increasing the tidal volume will increase in inspiratory time. While setting the IA ratio, you should be very careful about the interplay between various parameters. Then we adjust the trigger. There are two ways to initiate ventilator deliver the breath. Pressure triggering, initiated if the demand valve senses a negative airway pressure deflection generated by the patient trying to initiate a breath greater than the trigger sensitivity. We usually set sensitivity between -1 to -3 centimeter of water. In flow triggering, initiated when the return flow is less than the delivered flow, a consequence of patient's effort to initiate breath. The trigger sensitivity is usually set 2 liters per minute. In this figure, we see the pressure tracing in the upper part and the flow tracing in the lower part. In the upper part, we can see the pressure triggering by a negative deflection before initiating inspiration. The lower part, we see the flow triggering by declining flow in the flow diagram. Here is a summary of different modes of mechanical ventilation. Stay safe, stay home. Thank you.